class. Welcome back to our chemistry class after some time. Today's class is going to be an interesting class in which we'll be discussing chemical combinations. Chemical combinations is brought about by the coming together of atoms whenever they want to attain a stable electronic configuration. Let's say, for instance, we have some atoms of group 0 element, which is group 8 element, talking about the helium with an atomic number of 2, neon, atomic number of 10, argon, atomic number of 18. When you look at this, according to what we have done in our previous classes, the earliest classes, our case shell here always contains 2 elements, 2 electrons rather. While here our case shell will contain 2 electrons, our L shell will contain 8 electrons. Here as well, case shell will contain 2 electrons, L shell 8 electrons, then M shell 8 electrons. And the maximum electron that K shell can contain is just 2. While the maximum electron that L can contain, M can contain, N can contain, and so on, the maximum is 8. Now, if you now look at this helium having 2 electrons, it means that the atoms of helium is stable. Likewise, atom of neutron and argon, they are all stable. But other groups, all the remaining elements or atoms in other groups, they are unstable. Say for instance, we have sodium. Sodium with an atomic number of 11. The K shell of sodium is 2, the L shell of sodium is 8, and the M shell of sodium is 1. And we know very well that our M must contain maximum number of 8 electrons, but now it's having 1 electrons. So having 1 electron in the outermost shell makes this sodium to become unstable. So sodium is unstable. Likewise, let's consider chlorine. Atomic number of 17. The K shell of chlorine contains 2, L shell contains 8, and my M shell will contain 7. When you look at this chlorine in this case, chlorine needs 1 to make up 8. So it's still unstable. It's still unstable. So anytime we are having an unstable atoms, at a particular time, they tend to either donate, lose electron, or they gain electron, or they even share electron in order to form a stable compound or a stable atom. In this case, this process is what we call chemical combination, when they are looking for a way of stability. Now, when 2 atoms now comes together, either by losing electron or gaining electron or sharing electron, this is what we call chemical bonding. Chemical bonding is the attractive force between atoms in order to form a stable electronic configuration. Fine. Let's consider this sodium. The K shell of sodium is having 2 electrons. The M shell of sodium is having 8 electrons. And the M shell, this is L shell, this M shell is having 1 electrons. Fine, this is sodium. Then for chlorine, the K shell of chlorine is having 2 electrons. The L shell is having 8 electrons, while the M shell is having 7 electrons. This is chlorine atom. This 1 electron in the outermost shell, or this 1 electron in the outermost shell here, is what we call valence electron. And this valence electron, they are the one taking part in the chemical bonding. They are the one taking part in the chemical bonding. So in this case, this sodium now, for this sodium to gain stability, to be stable, it has to lose this one electron. In losing that electron, that is when they become a cation. So when sodium loses one electron, it forms Na+. That is, it has lost one electron. Why this chlorine? For this chlorine to be stable, it has to gain the one electron coming from this sodium, and then it forms chloride ion. So this is Cl minus. Whenever you see a negative, it means that it has gained an electron. When it is positive, it has lost an electron. Now, let us now dive into the types of chemical combination. Types of chemical combination. There are two major types of chemical combination, although we have more than that, but the two major types of chemical combination are, the first one, we have electrovalent combination. The first one is electrovalent or ionic combination. The second one is covalent combination. Covalent combination. So this covalent combination, under it, we are going to have the first one called ordinary covalent combination. Ordinary covalent combination. Then the second one, we have dative covalent combination. Dative covalent combination. Now, if we have, so this one, they are under covalent combination. Then other types of combination, we talk about hydrogen bonding. We talk about hydrogen bonding. Then another one is van der Waals forces. Then we have metallic bonding. So these are the types of chemical combination that we have. Electrovalent or ionic combination, covalent combination. Under each, we have the ordinary covalent combination and dative covalent combination. Then hydrogen bonding, van der Waals forces, and metallic bonding. In today's class, we are going to be looking at electrovalent combination and probably covalent combination. So let's dive in. So the first one we looked into is the electrovalent or ionic combination. What is ionic combination or electrovalent combination? This is a complete transfer of electrons from a metallic atom to a non-metallic atom. So one is a transfer of electrons from metal to non-metal. A complete one now we refer as electrovalent combination or ionic combination. Let's say, for example, example 1, formation of sodium chloride. We have sodium chloride, that is NaCl. It is made up of sodium with atomic number of 11 and chlorine with atomic number of 17. Then we have sodium. The K shell of sodium is going to be 2, L shell will be 8, and M shell is going to be 1. While for chlorine, the K shell is 2, L shell is 8, M shell is 7. When we draw the electronic structure of sodium, K shell, M shell, this is L shell, and this is M shell. So this is sodium atom. Sodium atom. Combining with chlorine. Combining with chlorine, the K shell of chlorine, the L shell of chlorine, and the M shell of chlorine, having an electron of 7 in the outermost shell. So this is chlorine atom. Now in this case, sodium has 1 electron in the outermost shell, while chlorine possesses 7 electrons in the outermost shell. So for this chlorine to balance with 8, which is called octet rule. when it completes 8, it means it has to accept one electron coming from sodium atom. So this sodium has to transfer this one electron to this particular chlorine atom to now form. So when it lost that one electron, this M shell cease to exist. So we are going to add something this way. The K shell and the L shell. So this one now is going to be having plus positive. So this is called sodium ion. Sodium ion, that is Na plus, carrying positive charge. While this chlorine accepting the one electron, the K shell L shell so the one electron coming from this sodium is this. So this has taken one electron. So it is now called chloride ion. That is Cl minus. So the formation when sodium atom Na combined with chlorine atom is going to give us sodium and chlorine. This is called sodium chloride. So this is the formation of sodium chloride as an electrovalent combination. Example 2. Formation of calcium chloride. Calcium chloride. Calcium belongs to group 2. We have calcium CaCl2. So this is the formula for calcium chloride. In this calcium chloride, we have calcium having atomic number of 20. Then chlorine, we have 2 chlorine. The first chlorine 17, the next chlorine 17. Our K shell here having 2 electrons, L shell having 8 electrons, then the remaining M will have 2 electrons. Therefore, chlorine, we've done that before. K shell is 2, L shell is 8, and our M shell is 7. K 2, M, L rather, 8, and our M is 7. Now, let us now draw the electronic structure of this calcium. The K shell having 2 electrons, L shell having 8 electrons, the M shell is having 2 electrons. So this one is called calcium atom. That is Ca. Combining with chlorine atom, the first chlorine having K 2 electrons, L having 8 electrons, then our M having 7 electrons. Then this is chlorine atom, Cl. Then the second chlorine, K shell having 2 electrons, L shell having 8 electrons, and the M shell then having 7 electrons. This is second chlorine atom rather. Now, in this case, there's going to be a transfer of electrons because this calcium atom is not stable. It needs 6 more electrons to be stable. The first chlorine needs 1 electron, second chlorine needs 1 electron. Now, in order for them to balance, for a calcium to balance, it has to transfer this electron to this place, while this one has to transfer its own electron to this place. So when they transfer it, the M shell here will cease to exist. So we are going to have, for the calcium, we have something this way, K shell, the L shell having its own 8 electrons, Now it has lost 2 electrons, that is 2 plus. Then chlorine, this we gain. They are gaining 1 electron each. L shell, M shell. So the 1 electron coming from this particular calcium atom is this. Then for the second chlorine as well, our K shell, L shell, so 1 electron is also coming from the second electron, this is. So in this case, this one is gaining 1 electron. This one also is gaining 1 electron. So these are chloride ions to form calcium chloride. So this is the formation of calcium chloride. So calcium chloride is an example of electrovalent combination or ionic combination. Other examples, we can have sodium oxide. We can have calcium fluoride. Any combination that involves a metal and a non-metal, where there's going to be a complete transfer of electrons from that metal to non-metal, is what we refer to as electrovalent combination or ionic combination. Let's take an example of sodium oxide. The next example is the formation of sodium oxide. Before we go on to this, I want to remind you not to forget to subscribe to my channel and leave a comment. Don't forget to also share to your loved ones. Now, formation of sodium oxide. In sodium oxide, this is a combination of 2 atoms of sodium and 1 atom of oxygen. Sodium, which is a metal, atomic number of 11. The other sodium, which is a metal, atomic number of 11. Then oxygen, a non-metal, atomic number of 8. Sodium having a K shell of 2, L shell of 8, and M shell of 1. Likewise here, K equals 2, L equals 8, M equals 1. Then K shell of this one is 2, L shell is 8. Now I want to write the electronic configuration of this. For sodium, our K shell having 2 electrons, our L shell having 8 electrons, our M shell having the remaining 1 electron. This is sodium atom. Combining with another sodium atom, K shell, L shell having 2 electrons, then my M shell having 1 electron. Then combining with oxygen having a K shell of 2 electrons and the L shell of 6 electrons. 6, because total is 8, this is going to be 6 electrons. So we are going to have 2, 4, 5, 6. So this is oxygen atom. The first electron here, this one has to balance. It needs 7 electrons to be stable. And it's not possible to accept 7 electrons. So, but it's easier for it to lose that 1 electron to this. Losing 1 electron here. Also, this one also lose 1 electron here. So when they lose that electron, we are going to form. So our sodium atom now forms something this way. K shell, L shell. So it has lost the outermost shell, which is the M shell. So now it forms sodium ion. Why this other one, this sodium ion also lost one electron. It's a combination. See, they are combining together now. So it's L shell. So this is L shell. Therefore, oxygen, the K shell and the M shell too, 4. Now, the first electron coming here, and second electron coming here. This is a formation of sodium oxide. So this is how to undergo the formation of electrovalent combination. Don't forget, we have other examples. So far, they are combination of metal and non-metal, talking about sodium chloride, calcium fluoride, sodium oxide, aluminum oxide, and so on. They are examples of electrovalent or ionic combination. If you find this class so interesting, kindly subscribe to my channel and click the notification bell for my subsequent contents. But you have to do me a favor, try to share to other loved ones for them to benefit. We're going to meet in the next class where we'll be talking about the covalent combination. Thank you very much.